the point. We were actually right here. What on earth did I do? Look at your forever card. Is this the derivative of sine inverse of x? Yes or no? Some of you are like, okay, what's different from x? And the forever card has a u, but okay. Don't we build chain rule derivatives off of basic derivatives? Okay, so I'm just putting in u's because we've done chain rule now, so why not make it a rule where you can count u and a u prime? Okay, coming back. So how on earth did I get here to here? This is a skill that you're not going to necessarily need to test. However, it is helpful for Calc 2 and a few things that you might see in Calc 2 at some point. What's going on? I went and said, hey, we don't have a forever card yet. We don't have a rule yet. Do we know how to just take the derivative, deal with that? But it was to switch, and technically, I should say, switching does work in this one, but technically what we're doing is taking sine of both sides, is making it something that I do know. Hey, why am I crossing out sine and sine inverse? Ooh, that's a good one for homework, right, AJ? She got to something tricky last night. Why did I cross out sine and sine inverse? Yeah, inverse functions do. What? Undo. Yeah, they undo each other. Square root and a square root, an e and an ln and an e, right? They undo each other. So sine of sine inverse undoes. X is left and sine of y is left. Take the derivative of both sides. No big deal. I got this. Implicit. Check. Implicit. Check. Y prime dy dx. Solve. Ha. Done. This doesn't match your forever card, though, because the forever card says that we x's. X's. We could sine inverse of x, but if you get your forever card, it wants more than that. So what I did was say, hey, wait a minute, hold on. Sine of something always gives me a ratio. So I put x over 1 and said, hey, that's an opposite SOHCAHTOA, an opposite over hypotenuse. I labeled a right triangle with opposite hypotenuse. Trig is always of an angle, so I put that in the angle spot. How did I get this side? Yeah, a squared plus b squared is c squared. So how do I find a? Square root of c squared minus b squared. It's just a variation of Pythagorean theorem. Why did I fill in a right triangle? Because what did I need at the end? Cosine of who? Of him. Oh, easy. Adjacent over hypotenuse. Plug it in, done. So I'm going to show you a couple more, just giving you the idea, but then we're just going to practice with the rules to finish off section 2.6b. And some of your classmates actually busted out the majority of the homework last night because, you got it? You're welcome. Busted out the majority of homework last night because they found rules and they said, whatever, they're rules, we'll use them. And that's what you're going to have to do tonight. Now that you have the forever card, some of you had it earlier, some of you have it now. They're new rules. Use them. Get used to them. Figure out ways of memorizing them. I haven't had somebody yet come up with a really good way, whether singing or chanting or whatever, to memorize all of the rules. We just kind of do it. If you guys come up with a fun way, some of you are very creative in studying, let me know. I'd love to steal it and pass it on to others. So, take the derivative. There's a rule. Yeah, but we're looking at behind the rule. We're looking at behind the rule. Now I'm going to go ahead and write the rule just because we are supposed to be learning and memorizing it. So if we were trying to find d dx of tangent inverse of u, guys, go ahead. What's the forever card say? Times? U prime. Good. Okay, so we're going to use that to check our answer at the end. And for homework, you're going to go straight here. But just a few of you, the triangle thing is going to end up being helpful eventually. We're going to go take tangent of both sides because we're assuming we don't know how to do tangent inverse. Or we're saying that we can't use the rule because we want to see behind the rule. What's going to cross out? Tangent and tangent inverse. So we end up with the equation, let's go ahead in this color, 2x to tangent of y. Our end game is dy dx, so what are we going to do now that it's written like this, guys? Just go implicitly, derive both sides. You guys, get ahead of me a little bit. You should be able to do the implicit. I want you to find dy dx. As you do, I'm going to come over here and play with my triangle, giving you a little bit of time to do what you do. Take the derivative. Forget your u prime, y prime. I got distracted for opening the door because now it's quite warm. But the door is open. Hopefully it'll cool down soon. Once you think you have the derivative, I'm going to go over and solve for the derivative now. Maybe you guys can ponder what I filled in and whether or not it makes sense. And maybe, just maybe, you can keep going with the triangle because I only filled in what came straight out of here. There's something else we can fill in with a little bit of math and Pythagorean theorem, that is. Did anybody think of making 1 over secant cosine? No? It's okay. It's okay. I'll leave it like that. Well. I'll do an or. Reciprocal of secant is cosine. Same thing. Has anyone had time to consider the triangle and fill in or think about filling in something? What's missing in the triangle? The hypotenuse. How do I find the hypotenuse if I know the legs? A squared plus equals. But I want just c, so aren't I going to square root the whole thing? And a squared plus, who's b squared? You guys know what I mean, right? Quantity 2x, 2x times 2x, 4x squared. Well, how does that help me? How do I get trig? I look for ratios. Now pause, just in case you didn't know where this came from. Whatever is inside a normal trig angle, so I labeled my angle. For that angle, tangent, so SOHCAHTOA, is opposite over adjacent. So 2x, you can put them over 1. 2x could be my opposite, 1 could be my adjacent, at least the ratio. You guys can think of what your brain did. If you didn't think about making squared cosine squared, then let's find secant. How do we find secant of a right triangle? Is 1 over. So if it's 1 over sine, it's an over hypotenuse. Hypotenuse over. Where does that get plugged in? Okay, so what are you going to do? Move the squared to the outside, and who gets plugged in? Oh, square root squared. What ends up happening? Aren't they inverses, just like those guys are? Didn't I say we were going to check with that formula up there? Check with that formula. Couldn't we come back to the very beginning and say, wait a minute, if I'm trying to take the derivative of y equals tangent inverse of 2x, couldn't I say that f is equal to tangent inverse of u, where u is equal to 2x, right? So I'm going to take the derivative of the outside times, oh wait, hold on, I can just use my rule, because my rule says 1 over 1 plus who squared? U squared times u prime. Now some of you are like, oh, okay, I'm thankful for the rule because that's a mess. This is the behind the scenes, using implicit differentiation to go ahead and solve. But guys, do they end up being the same? I could keep going and I could find technically all 6 of those forever card rules and show you where they all come from using a right triangle, whether it's an X or whether it's a U. It'll always work out. But I think it's time for us, oh, we already did that one. I think it's time for us just to practice some forever card rules, yeah? You guys have those rules already? Okay, no triangle written. How come? Because we're just going to use the rule. That's okay. That's the main point. That's what we need to be able to do. If you ever were to forget the rule, I guess you could always make a triangle if you knew how. My goal is for you to memorize and use the rule. So someone help me out. What's the derivative of sine inverse of? Hey, is there another derivative rule of those 6 that looks a lot like this one? Hey, are there kind of really pairs for every single formula? Sine inverse looks like cosine inverse, just cosine inverse has a, hey, the derivative of cosine had a negative also. Huh? What other 2 look alike? Derivative of tangent inverse with derivative of cotangent inverse, but cotangent inverse has a, hey, like the derivative of cotangent had a negative. What are the other 2 that pair up? Secant and cosecant, except cosecant inverse has a derivative of cosecant. Are there? Yeah. Hey, what's the derivative of just tangent? Secant squared. What's the derivative of cotangent? With a secant squared. Aren't those very similar in their derivatives? So the same way that tangent and cotangent are very similar in their derivatives, tangent inverse and cotangent inverse very similar. The same way that sine and cosine are very similar, sine inverse and cosine inverse are very similar. Actually, they're exactly the same, except cosine inverse has a negative. There are patterns. Even though there are 6 formulas, you really only have to remember 3 different things. Anyway, we'll keep going from here. Who's my U? Ugh. I don't like 1 over x. So wait a minute. If I want dy dx, or f prime of x, couldn't I just go straight to my formula and say 1 over the square root of 1 minus who squared? Times who prime? U prime. Anybody have any ideas about how to do that one? Close. It's not 1 over x squared, but you're close. Why is it negative 1 over x squared? Pause. Some of you didn't even think of making it x to the negative 1. So what rule should you have been thinking instead? Quotient rule. And if you did bottom d top, derivative of 1 is 0, minus top d bottom is 1, all over bottom squared, you're going to get to the same place. So whatever you need to do, get the u prime right. But rewriting does help. So we had our u, rewrote it, made it easier, bringing down the negative 1, subtracting 1, negative 2 power. If this was a long answer question, you'd be golden, but here's the thing you have to work on homework is making it match. So what do you think we need to do? Simplify. Why is it messy? Yeah, but I would think the complex fraction makes it even worse, right? Okay. Here's a little bit of a struggle. We could rewrite this to be negative 1 over x squared. Do you know how we have that trick for complex fractions? Multiply top and bottom by the, remember? Reciprocal. But by the stuck guy? Can I just multiply by x? Can this come in and help me out? But what could? Ooh. Do a square root of x squared. Then I can go ahead and bring it under square root or into the square root, and now things get a little bit better. So now I could say, okay, I have negative square root of x squared all over. And so then we go ahead and distribute. So it's going to be an x. 1. Now this gets a little rough. What do you guys see in that numerator that you might want to do? Yeah, right? Take it out. And if you take it out, you're almost good. Because if you take it out, aren't you going to want to simplify it with that guy? So why is the final answer going to be this instead? Where did the absolute value come from? What's the sign of anything squared? Positive. What's the sign of anything squared and then square rooted? Ignore that. What's the sign of anything squared and square rooted? But if the absolute value wasn't there, what could x have a sign of? Positive or negative. It's a quick property from Algebra 1, but whenever you square, technically it's always an absolute. And we are allowed to reduce an x with an x squared, but when we take away the squared, positive, positive, I have to make sure he stays positive. Why am I showing you this? Because this is going to be an answer, but so is none of these. And I don't want you guys to hit none of these just because you don't understand why the absolute value is there. Does that make sense? So when you square root a squared, always absolute value. Technically in Algebra 1 thing that kind of got lost somewhere along the way. We can reduce these, but we have to say, this needs to always stay positive with the negative 1 somewhere else. Always has to stay positive with the negative 1 somewhere else. Okay, was this messy? Totally. Why? Because it was a little complex fraction that ended up happening. But how was the rule? Not terrible. Just the simplifying got kind of messy on that one. So let's go find another guy. What if... You guys know what's coming. As soon as you learn a new rule, you get put inside something else and you have to use it in the midst of using another rule. Another rule? Oh, come on. You know it. What rule are we using for this guy? Yeah. Got a first and we got a second. No stress. The rule starts out easy. Because to start out, all we have to do is rewrite the sign inverse, right? Tell me. Second. Derivative of e to the x is? You know it. Plus first d. Okay. New rule. Right? All right, so what's the derivative of sine inverse of u? You can use your forever card, don't worry. You're going to memorize it. Of 1 minus u squared times u prime. Are we okay? Ryan?
If you're doing u squared and u is 3x, wouldn't you square that and it'll turn into minus 3?
So right now I was, oh, sorry, thank you. I put my parenthesis in the wrong place. Thank you, Ryan. I was trying to take it step by step, thinking in my head 9x squared and being like, oh, I should probably show them what's about to happen. And in doing so, I wrote the squared in the wrong place. Thank you, Ryan. Hey. I'm trying to show you. Anything in common? The e to the x. This one is not going to make a huge difference. I bet you guys would see that even later. But we have sine inverse of 3x plus. Now I do need to warn just a few of you. This is the end of the road. We're done. I need to warn just a few of you. You cannot square root this expression. You'd be killing a puppy if you try to go further. It's illegal. Can anyone help me out why? What would be the factoring of 1 minus 9x squared? 1 plus 3x. Careful. 1 plus 3x and 1 minus 3x. Just because of the order of it, Ryan. So 1 plus 3x and 1 minus 3x. Can I make that something squared? No, they're different. 1 plus and 1 minus. So can I square root it if it's not a perfect square? No. Okay, dun 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 dun. Sorry, that's a beauty mark. I don't know what's going on. There we go. Pause. Questions? Have we practiced the sine inverse rule a lot? Yeah. Does that mean we've kind of practiced the cosine inverse rule? Just the only thing that would change would be a negative. So let's practice another tangent inverse one. But we just did a tangent inverse a second ago, so you guys go. I've been talking so much, man, you're probably so bored of my voice. So go. I don't know, I'm bored of my voice. So go. Don't worry, I have thick skin. Sometimes. You guys got your forever card. Take it away. All right, check in your groups. Not just how you plugged in, but how you simplified. Okay, my turn. Can I play? You guys agree? What did I do that I didn't show? I factored out a 2 and then, right? Okay, so not bad. 1 over 1 plus u squared times u prime. Oh, but who's this guy? All right, question. Sorry. We good? Okay. Everyone collective? Sigh. All right, well, one of you let it out. The rest of you already did. Here we go. New rule. We haven't used this one yet. New rule. We haven't used this one yet. So let me write it down. You guys help me out. What's the derivative of It's a c. So before we do anything else, we can already make it a negative. We know it's 1 over. They all are. Absolute value of u. Wait, u squared minus 1 looks like, oh, no. Sine inverse, cosine inverse. Okay, so they're similar but different. All things that need to be similar but different. But once we have the rule, you guys see how we're just plugging and chugging. We just need to memorize the rules, right? So cosecant, negative 1. It's a negative. Square root of, okay, that guy squared. Minus 1 times that guy prime. Okay. Done. Well, kind of. I mean, what are we going to change? Why is the final answer going to be what I do and was it legal? Wait, you can't take a 5 out of an absolute value because, wait. What kind of number is a 5? Is it a positive or a negative? So if I pull out a positive from an absolute value, have I really messed up with the meaning at all? No. So I can reduce the coefficient. That's fine. The guy I have to be careful of is the x. The x can't randomly lose his absolute value. It's pretty important. In the sense of saying, oh, he has to always be positive. Okay, I'll leave him there. Because if I take away the absolute value, it could be positive or negative. My values will change half the time. But otherwise, I just squared it, and I'm done. Can you go any further? Nope, you're killing puppies if you do. You're killing puppies if you do. So what about this guy? Oh. What do you mean it's the same thing? What do you mean find the slope at an indicated point? What is that? Do you guys see how there's nothing new as far as the type of question? What's new is they're just, oh, you can handle harder stuff now. Oh, okay. So how am I going to derive? Both sides. What rule am I going to use? Product rule. I'm going to use product rule. And in the midst of product rule, I'm going to use tangent inverse, which you guys were very proud of yourselves a second ago for. So show it off again in a different type of problem. That might just be a little bit harder. And let me close the door because now I'm cold. Or at least getting cold. I'm going to start playing, but I'm giving you a chance to get ahead of me. Sorry, some of you it's a little bit small with that y way up there in the exponent. Wait, who's arctan? Who is that guy? Oh, I just do the same thing? Yeah, no stress. Who is x? Nice. And the derivative of e to the u is e to the u times u prime. Y prime. Could we make it pretty? Yeah. But as soon as you say or see the at, say the at in your head, see the at. What is it really just saying to do? And not just plug into the derivative, which is why we had to do that first. But if it says to plug into the derivative, it's your choice. Do you want to make it pretty first and then plug in, or you just want to plug in and get numbers and then deal with the pretty? What do you guys want? Plug in first or pretty first? That's what I thought. So let's do arctan of, oh no. Are we supposed to know that? Times 1, whatever, that's just going to be itself. E to the ln of pi over 4. Is there anything we can simplify? Well, okay, that's easy, right? That's 1/2. We have some pre-cal stuff we have to remember. What's e to the ln of anything? What happens here? It reduces away, it undoes each other, and what's left? Okay, to the ln, inverses, pi over 4 is left. Oh, arctangent, tangent inverse. Pi over 4, but why? At what angle would sine over cosine equal 1? Oh, pi over 4. So we could do a quick little, I don't even know what we would do. To be honest, I would probably make it like that, and I'd multiply by the reciprocal. You guys can go ahead and pack up and get going. I'm just going to make this, 4s will reduce. A pi plus 2 over pi. Bye, cool kids. We need to start 2-7, so we're going to be working on that tomorrow and Fridays, hard as we can.
I forgot last night I was before I went to bed, I was like, oh, I need my gov charts, like I haven't done them yet. And then for some reason, I just went